So in this problem, we have ourselves a square. Let's see, what else can we draw? What can I draw here? I want to draw a square. There we go. So let's draw a square. And I know the area of that square, and I want to figure out how long are the diagonals. So a diagonal goes from corner to corner. D for diagonal. Okay, and this happens to be a right triangle. So if I were to be able to find the side lengths, I could use Pythagoras and figure out what that diagonal is. Okay, perfectly sane way to do this. 1800 equals s squared. So s is the square root of 1800, which 1800 is 900 times 2, which is like 30 times the square root of 2. If we're going to simplify this, sorry, it's not an 8, that's an s. So if both of these sides are 30 roots of 2, and I were to apply the Pythagorean theorem, that would look like 30 root 2 squared. And of course you can decimalize these. There's nothing that says you can't. Equals d squared. Okay, so when I do this, I get 1800, and I get 1800. So adding together, this is 3600. And taking the square root of both sides, I think that's 60. That seems right. This has a diagonal of 60. Okay, so that's one way to do it if you wanted to use Pythagoras. Now, we also should recognize that a square is a rhombus. So let me see if I am able to twist this around a little bit. There we go. Not exactly rhombus-like, but close enough. So if I want to find the diagonal of a rhombus, I'm going to use the formulas, because the formula of a rhombus wants you to figure out what the diagonals are. So let's see if we can do this straight away. 1800 equals 1/2 of d times d. Remember, the diagonals of a square are the same. So if I times both sides by 2, here we go, 3600 equals d times d, which is d squared. And then when I square root both sides, I get 60 as the length of the diagonal. So a lot more direct, but maybe you didn't think about that or didn't remember that the diagonals of a square are the same. So they're one variable.